going to head over to Mr. Steve Perkins from the Steve Perkins Associates, who's going to tell us about how he ensured that dust control was effective on what used to be known as the biggest car park in the world, the M25, and a substantial project he's involved in there. So over to you, Steve. Thanks very much for joining.
Thanks, Julian. Yeah, and just to make this even more topical, we've got some building work going on outside our office. So if you hear any thuds or bangs, that's what it is. Okay, if you could advance the slide, please. So morning, everybody, or good afternoon, actually. I'm Steve Perkins, Managing Director of Steve Perkins Associates, and we're a specialist occupational hygiene and health consultancy aiming to improve worker health protection, primarily in construction and infrastructure. We've got several experienced chartered occupational hygienists, ergonomists and health and safety professionals who cover a whole range of topics from risk assessment and management to culture change and control improvement. Prior to running our consultancy, I served for 9 years as the first chief exec of BOHS. Kevin Bampton's the current chief exec who's on the call today. And that's BOHS is the UK's chartered professional body and examinations board for occupational hygiene. So I want to get really practical. I'm going to share a case study with you from our work with an organisation called Connect Plus and their supply chain. Connect Plus, or CP, is the client organisation for the operation, renewal, maintenance and improvement of the M25 road network. And I hope this will illustrate some key points in getting the most from your engineering controls across the whole range of construction, not just in the highways sector. So, the M25, or as Highways England like to call it, Area 5, consists of 440 kilometres of motorways, 5 tunnels, 748 bridges, thousands of roadside assets. It carries 15% of all motorway traffic and is probably the busiest motorway in Western Europe. If you could click, great. And Connect Plus has a 30-year, £6.2 billion DBFO contract with Highways England to operate, maintain, renew and improve these assets. And we're currently about 11 years into that, so there's another 19 years to run. The supply chain for this includes their strategic partner Connect Plus Services and main framework contractors Tarmac, Milestone, Osborne, Jackson, R&W, and many, many other design, build and technical contractors. And together that supply chain of hundreds of companies is known collectively as the M25 community. So Connect Plus recognised that although the community had made great strides in safety and good progress on well-being and mental health, physical health protection continued to lag. Like most of the construction industry, protecting workers from occupational exposures that cause long latency, debilitating and fatal disease was definitely the Cinderella to accident prevention. So in 2019, we entered a partnership with Connect Plus and the community to begin the journey to change this situation through an initiative we developed called Healthier Highways. Healthier Highways is a holistic approach to health protection with 3 core programs. The first is an innovative awareness campaign that aims to raise understanding and influence workplace culture on health. The second is a program of occupational hygiene interventions and control improvements to tackle some of the biggest risks and demonstrate how health protection improvement can be achieved in practice. Given that most people haven't got a clue what occupational hygiene actually is and are usually bamboozled when you first say the word, that aspect of demonstrating what it does is really quite important. The third is a program of strategic management tools and metrics development to improve supply chain management of health protection. Because as we all know, and Peter Drucker famously said, what gets measured gets managed. I hope to illustrate that in a few minutes. If you want to find out more, just for interest, about the Healthier Highways initiative, and you can download a free brochure, just go to the Connect Plus corporate website at connectplusm25.co.uk/connect plus/healthier-highways, and there's a few pages on there that explain things. So today I'm going to focus in on a particular aspect of our occupational hygiene intervention and control improvement program. Road resurfaces, as I'm sure you're aware, is a ubiquitous task in the highway sector. On the M25, it happens at night to minimise traffic delays, and it's basically almost a 365 days a year activity. To resurface, you've first got to plane off the old asphalt, typically about 50 millimetres. And it's no surprise, but this generates huge amounts of dust. And I just want to show you a quick 20-second video clip that really does illustrate the problem quite markedly. So basically it's dusty. We partnered with Tarmac, Milestone and their resurfacing supply chains. Tarmac and Milestone are the main resurfacing framework contractors, to begin with a program of personal exposure monitoring of planer crews. So the guys who operate and walk around those machines while they're working. We did this on multiple shifts in a range of weather conditions because hygienists like statistics, so they have to get enough data to make sure the answers are believable. You'll be pleased to know that with asphalt planing, we found that silica dust levels were relatively low, probably about a third of the recommended exposure limit. Of course, if they were planing concrete, of which there are concrete surfaces on the M25, that would be very different. We also found that inhalable dust levels, I think inhalable and respirable were mentioned earlier, just quite simply. Inhalable is what gets into the upper respiratory tract, the nose, the mouth, sort of upper part there. And respirable is what gets down into the deep lung, into the alveoli in the lung and causes really quite a lot of damage. So what we found was that the inhalable fraction was significant but not excessive, so we weren't too worried about that. However, respirable dust levels were near or above the advisory exposure limit from the Institute of Occupational Medicine. As you can see from that chart there, that's different workers who work on the planing crew and their exposure levels compared with that limit. And it's that respirable dust that penetrates into the deep lung that causes those COPD type diseases that were illustrated so graphically and poignantly with Doug's video earlier. So everybody agreed straight away that action was required. There was no doubt about that as soon as we had the measurements. We also found that workers had some little awareness of dust risk, but definitely more education was needed. And that, to be honest, the existing risk assessments were pretty poor. And we've already talked about risk assessment quality, and it was great to hear Keith talk about, training people to write risk assessments. That's certainly a great need in our experience in construction. Shockingly also, it turned out that the planing sector as a whole had actually been working to HSE's old occupational exposure limits for inhalable and respirable dust of 10 and 4 milligrams per cubic metre. They were actually withdrawn in 2011 when new health effects data emerged at lower levels. I was back at BOHS then as CEO, and we held the debate where all that sort of stuff, new evidence was discussed. So we recommended using IOM's advisory limits of 5 and 1 for inhalable and respirable respectively, and obviously working to as low as reasonably practicable. So the question then is, what is as low as reasonably practicable, or what is reasonably practicable with one of these big planers? Well, it turns out that the large planing machines used on the M25 have two really good engineering control systems for dust. The first is a vacuum cutting system, or VCS, which sucks away dust from the planing drum head at number 4 and deposits it on the conveyor belt at number 5. The second is a water sprinkling system shown in the right-hand diagram by the yellow tubes. This allows water to be applied to the drum, thus protecting the tools on the drum head. Everybody's worried about tools, obviously. And it also allows water to be sprayed onto the belt to damp down all that dust you saw blowing off on the conveyor in the video. To progress the project collaboratively, we formed a surfacing supply chain working group involving senior leaders and managers from all the contractors, and we managed to get the planing manufacturer, Vertgun, involved as well. They're multinational. And discussions within the working group and with the operatives we met on the ground revealed some really interesting findings. Firstly, we discovered that the planers were not being maintained as per the manufacturer's specifications. This meant that the VCS dump valve was not being regularly opened and cleaned, which reduces the efficiency of vacuum extraction. It's basically like having a vacuum cleaner at home, letting it fill up with dust and still expecting it to pick up more. I mean, it doesn't. You've got to maintain it. Secondly, the most significant thing we discovered was that in the planing industry, it was standard practice to manually turn off the water sprinkling on the conveyor belt, basically disabling the most important engineering dust control on the machine. Now, to us, that was shocking, but as we delved deeper, it turned out that everyone from operatives right up to directors believed that was actually the right thing to do for several apparently legitimate reasons, which created a cultural norm around saving water in the planing industry. So we went about disproving all of them, basically, and here were the 4 reasons. The first one was a belief that the tailings from planing, so that's the material that gets dumped in the truck, it goes off to recycling, and everybody believed that that material needed to be dry when it went into the recycling plants. So we spoke to the directors of those plants. Turned out that's not true at all. They put no specification on water content of tailings, and in fact, they store them outside in all weathers. Secondly, because water usage is measured as an environmental resource, everyone felt a pressure to conserve it. As I said earlier, what gets measured gets managed. So, you know, the fact that it falls out of the sky quite regularly in the UK compared with the fact that we only have 2 lungs didn't seem to come into the equation because they just weren't aware of the dangers to lungs from dust. So I would say with whatever your metrics are, be careful what you wish for. Thirdly, people were concerned there would be a need to refill the planer's water tank during a shift, which would delay the job and incur extra cost. However, our calculations with the manufacturer showed that for the short planing windows on the M25, a full tank of water was more than enough to complete every job with the sprinkling system running at 100% everywhere. Finally, there was a concern that spraying more water would make the carriageway excessively wet for the cleaning sweepers preparing the plane surface for the next part of the process. However, planing is conducted in all weathers and the cleaners are meant to spray water anyway, so that was a bit of a no-no. It was only really through honest and open conversations within the working group, and I've got to say, all credit to the leaders of these companies on the M25 for having the courage to let us do the exposure measurements and find out what was really going on. Very few companies actually will do that. It's only through those conversations that we were able to get to the bottom of things, and we got collective agreement in the whole working group that basically none of those reasons applied in M25 planing work, and hence there were no operational or commercial reasons why water spray should be turned off on the conveyor belts. But just to put the nail of the coffin into that culture, we decided it was necessary to conclusively prove this. So what we did was we conducted a further round of exposure measurement, this time using static samplers located at different points around the planer. You can see those yellow indicators there on the photograph. In the lower photograph, you can see all the manual valve controls on the planer sprinkling system. The far right one is the spray on the conveyor, which is in the off position at the moment. Restricting water spray to the drum results in an average increase in respirable dust levels of 120% and inhalable dust levels of 80%. So basically, if you turn off the water spray on the belt, the dust levels double and they become dangerous. And you can see that from the difference between the red and the blue bars on the graph. So our recommendations from these results were that surfacing contractors should ensure that water is supplied to all the spray nozzles where cutting is conducted, drum and belts, at 100% and not manually restricted. We did have a debate around whether we could get the manufacturer to basically disable the ability to turn off the water. That would obviously be the ideal situation. Unfortunately, as I said, there are multinationals selling these all over the world in lots of different conditions, and they, at this point in time, they're not prepared to do that. Surfacing contractors should also ensure they have adequate checks and maintenance in place for the VCS fan and ducting to satisfy the cost regulations. Basically, it's an LEV system. Framework contractors should then ensure checks are in place to assure all of the above. And the planing manufacturer should consider developing guidance for the planing industry on the thorough examination and test of the planer's LEV systems in line with HSE guidance. I'm pleased to say all these recommendations are being implemented through our working group, so that now on the M25, if anyone sees a plume of dust from a planer, they know to immediately stop the job, as that should definitely not be happening. I said earlier that road resurfacing is ubiquitous across highways. The challenges we encounter with planing on the M25 are most likely occurring across the whole of the UK's road network. Our findings about water sprinkling controls could provide a huge health benefit if replicated elsewhere. And that's why, along with our partner Connect Plus, we are trying to communicate our findings with Highways England and the wider sector. So we really appreciate the opportunity today just to, get this story out from RVT helping us with this. So thank you for that. However, I mean, obviously we've focused on a highways case study there, but I do think there are some transferable learnings on engineering controls that can be applied more widely in construction. So firstly, and obviously, I'd say make sure you understand what controls you already have, how they work, and what you need to do to maintain them properly. Even simple water spray on a still saw, make sure you know how it works and that you're familiar with how it works. Secondly, take the time to check on site and actually talk to operatives to understand if or how these controls are actually used in practice. Just because a RAM says something does not mean that's what is actually happening. There's no substitute for getting out on site. Next, if you discover problems to the use of controls, focus on removing the barriers. Try and make it easy for people to do the right things. That's partly why we did that second round of exposure testing, so we could conclusively prove it and demonstrate to both operatives, supervisors, managers, and higher up the chain, what's really going on. And of course, regularly maintain your controls. Make sure LEV systems are functioning at their specified efficiency. And when appropriate, measure exposures to verify that controls are actually achieving the outcomes they're supposed to. We all know in everyday life, all the machines that we use around our homes gradually fail and get less efficient. How much more with controls like this that are being used in really challenging environments? So we actually do need to measure to check. And finally, train users in both what they need to do to use controls effectively, but also why it's important they do it. People need to know the why as well as the what. People are not robots who can simply be programmed by a task list. They need to have the reasoning explained to them and be allowed to ask questions about it. Well, I hope that's been interesting. Happy to take any questions later when we have the panel discussion. I'll hand back to you now, Julian.